Please answer the following question. Two planes start from the same city at the same time. One travels 252 miles per hour and the other at 266 miles per hour, in the opposite direction. How long will it take them for them to be 1,750 miles apart? You have 2 minutes.
Scary enough to send the bravest man running in fear. We're going to be talking about, that's right, dun dun dun, word problems. I'm going to give you several different ways to look at these and begin to solve these problems. We're going to be doing a lot of practice here the next couple of weeks. And I think you'll come away with several different strategies that will help you solve these. The first thing I want to put out there is that you will probably not understand the question the first pass through the problem. If you can, hey, that's totally awesome, but I can't. I have to read through the problem several times, and you'll see as we work some of these examples out today that I will be drawing pictures. I will be thinking about it, making some equations, maybe have to figure out the equations, and maybe even looking up definitions for, what exactly is this? So, thing number one, don't be intimidated by the problem. There are some steps we can take. We're going to walk through a few of those today. So let's get started. So our problem is 10 more than 3 times a number. And the question is where to begin. And one of the first ways I like to begin is to try and define what I'm looking for. So looking at this word problem, I see that there's something undefined here called number. And I'm just going to say, let's let number equal x for right now. Now, it often takes more than one pass through a word problem for you to figure out exactly what it's asking and to find all the pieces. So I'm going to take a look at this one, and we'll break it down a little bit. So I've got 10 more than 3 times our number. So I know I've got to have 3x because it's 3 times that number, and I know we're going to want 10 more, so it's basically 3x plus 10. So does that make sense? 3 times and 10 more. So 10 more than 3 times the number. Well, we've got 10 more, that's plus sign, then 3 times this number. And I'd say yes, we've figured out the expression that we're asking for. What's the first thing we did? We tried to find the variable that we were missing, or the unknown piece. So I'm just going to say find your unknown. And define your unknown. So we found that we have this mysterious thing called a number, and we defined that number as x. Let's take a look at this one. 2 numbers whose sum is 17. Now, anytime you want to try to just work on these on your own, feel free to pause the video and give it a try. 2 numbers whose sum is 17. So I look at this and I see 2 things. First of all, here's what we don't know, those 2 numbers. And so I'm going to say number 1 equals x, and I'll say number 2 equals y. And we also need that the sum has to be 17. Well, we know what sum is. It's when we add 2 numbers together. So this is going to be something like x plus y equals 17. Again, I want to stress that sometimes you have to read through these several times, and you'll have to go back and check your answer where you possibly can. So what do? We found our unknown. We've got some word in there that says two numbers. We don't know what those are. We defined our unknown. We said number 1 was x and number 2 was y. And then we begin to create our equation in this case. And then we're going to go back and check. So let's see if this makes sense. X and y are two numbers whose sum equal 17. So I would say, yeah, we're probably good on that one. Let's try another one. Two numbers whose difference is 48. Two numbers whose difference is 48. Well, what do we know? There's our two numbers that showed up again, so we'll just call number 1 x, and the second number is going to be our number 2. It's going to equal y. And whose difference? And what do we know about the difference? Well, we know the difference is subtraction, and we've got an answer here. So we're going to have x minus y equals 48. So we found our unknown. It's two numbers thing. We defined it. We just said number 1 equals x, number 2 equals y. And then we found that, oh, this is a difference problem. So we've got minus. So we had two numbers, x and y, whose difference is 48. X minus y equals 48. Let's try another one here. The amounts of antifreeze and water in 4 gallons of an antifreeze water solution. All right, this one seems to be a little bit tougher. Well, first, let's find our unknowns. What are we looking for? We're looking for the amounts of antifreeze and water. And we don't know what those amounts are. So let's just say that our antifreeze is going to equal A, and our water for right now is going to equal W. All right, so the amounts of antifreeze and water in 4 gallons of an antifreeze water solution. So we've kind of identified antifreeze and water, and now we have a 4-gallon antifreeze water solution. So what do we end up with? Well, we have A antifreeze. A is the amount. So we have so much antifreeze plus so much water. It's going to equal 4 gallons of our antifreeze water solution. I'm going to put solution. So what do we have? The amounts of antifreeze and water. So this is A is our amount of antifreeze. W is our amount of water. So this might be like 1 gallon antifreeze plus 2 gallons of water equals, well, that won't come out. So this might be like 2 gallons of antifreeze and 2 gallons of water to get a 4-gallon solution, but we don't know. It might be 1 gallon of antifreeze and 3 gallons of water. So our unknowns were the amounts of antifreeze and water, and we gave them the variable name capital A and capital W. And we kind of went back and checked our answer, and we said, yeah, sure, the amount, this much antifreeze plus this much water would get us a 4-gallon antifreeze water solution. Let's take a look at this one. So similar to the one we just worked on, but it looks like we might have some more information. But the first thing we need to do is go find our unknowns. So what unknowns? We've got the number of gallons of antifreeze in a radiator containing X gallons of mixture that is 11% antifreeze. So why don't you stop the video and let's see if we can find the unknowns and define those, and then come back. All right, so what are we looking for? Well, we're looking for the number of gallons of antifreeze. And so let's just use that again. I'm just going to use A for the, I'll just put number of gallons of antifreeze. Now we've got a radiator that contains X gallons, and we've got a mixture that's 11%. So we have a radiator that has X gallons at 11%. Wherever you can, picture the problem. Now, when I read through this, it's not exactly clear what I'm trying to do or how to lay this out, but so I'm going to redraw this a little bit, and let's see if I can't come up with something. So I've got a radiator. Here's my radiator, little radiator cap. There we go. So this is my car radiator or container of any kind, and I know that from the top to the bottom, it's going to have a mixture of antifreeze and water. I don't know how much it is. They call it X. What I do know is there's 11% is going to be antifreeze. So I'm just going to divide this out here a little bit. And here's my water. So the top half, all this up here is going to be water. And so there's 11% down here. And that would make this, what, 89% up here? All right. So if I take X times my water plus X times my antifreeze, 11%. This is going to equal the total amount. Now what we are looking for is just the amount of antifreeze, right? The number of gallons of antifreeze. We're going to call this A. So A is going to equal our total volume, whatever that X, right? But it's only going to have 11%. So 11%, or X times 11%. So our gallons of antifreeze in this tank is 11%, and so that's going to give us how much, how many gallons of antifreeze we have. So I find it very helpful a lot of times to draw out exactly what I'm trying to figure out. And it may be that I ended up with some intermediate calculations as I try to put this all together. That's perfectly fine if that happens. Like I said, what I find is helpful is try to picture the problem whenever you can. Go find your unknowns, define those unknowns, and then finally come back and check your answer. Looking at this, if we're going to check our answer, we have a tank filled with X, and we want 11% of that. And looking up here, we have a radiator containing X gallons. 11% is antifreeze, and we want to find the number of gallons, and that's exactly what this equation will give us. Okay, so let's take a look at this one. A fraction whose denominator is 4 more than 6 times the numerator. Well, we may have a problem right off the bat, and that is, do you remember what a denominator is? So if you don't remember what a denominator is, then you're going to have to look that up. And the same thing with a numerator. In technical questions, that happens quite often. You may have to go back and check definitions. So let me add that to our list of things. So we may have to check definitions. So if you go back to page 19 in your book, it will tell you what a denominator and a numerator is. So shut this off real quick and go take a look. So on page 19 under 1-4, it says a quantity A over B is also called a fraction, where A is the numerator, that's the one on top, and B is called the denominator, that's the one on bottom. That's going to help us a lot. So if we were to look down through here, let's see, find any unknowns. Well, we don't know exactly the number of the denominator or the numerator. Define your unknowns. Let's just do it like this. Let's just say that we're going to do A over B. Find a fraction whose denominator is 4 more than 6 times its numerator. All right, so we know the denominator, the one on bottom, has to be 6 times that of its numerator. I'm sorry. We know the denominator is 4 more than 6 times its numerator. So the number on the bottom has to be 4 more. So B has to equal 4 plus 6 times A. And there's our fraction. So it's A over 4 plus 6 times A. Didn't really need to picture this problem. Maybe there at some point we would need to. We did have to go check definitions. Let's go back and check our answer. So we need a fraction whose denominator is 4 more than 6 times its numerator. And here's what we've got. Our denominator is 4 plus, so it's 4 more than 6 times the numerator, or 6A, where A equals the numerator and B equals denominator. All right, very good. So let's try this one. If x equals the length of a rectangle, write the expression for the width of the rectangle if A, the parameter is 64, or B, the area is 320. So when I think rectangle, I picture an object. So that's what I'm going to do. I'm just going to draw myself a rectangle here. There's my rectangle. And it says x is the length. So here's my length. And we are wanting an expression for the width. So I'm going to go ahead and just draw me a W for my width here. So width equals W. All right. So I was looking for, so the first thing I did is basically draw a picture of the problem. So it's got another part. And that part is the parameter. If you know what parameter is, great. If not, this would be a great place for you to go check definitions. But let's talk about parameter. What is parameter? It's the outside. So we've got this plus this plus this plus this equals 64. So we've got one width here and one width there. We get 2w, and we've got an x here and an x there. So we would say that 2x plus 2w equals 64. So the parameter is 64. So write an expression for the width of a rectangle. And since it says expression, we don't want an equal sign. So we could say, we could subtract 64 off each side. We can say that. I don't like that very much. That's confusing to me. Let's do it this way. Let's subtract off the other part. Let's subtract off the 2x plus 2w. So we end up with 64 minus 2x plus 2w. There we go. That gives us the parameter. And that's an expression form. Okay, so the other one, that's A. Let's take a look at B. So B is the area of 320. So area would be the inside here, right? And the area is simply x times w, if you remember area. If not, you may go look it up. So what we have is x times w equals 320. Again, they said put it in expression form, so we could do 320 minus xw, and that would be expression form. And so if we knew what x was at any given time, we could calculate for w. We could just break our equation back down. And if we knew what x was for A, I'll put B down here. For A, when we've got a parameter 64, we could simply break our equation down and figure for width. We might be able to do more with this. I think I'll leave it at that for right now, just to give you an idea. But you see that we pictured the problem, and that made it much easier to go back and solve the problem that they ask in the question. Okay, let's do one we actually get to solve. So we've got 5 less than 4 times a number is 32. So what are our unknowns here? Well, I would say we've got the infamous number out here. So I'm going to say that number equals x, and we've got 5 less, which is going to be subtraction, and we've got 4 times, which is going to be multiplication, and we've got 32. So we've got x, I'll say 4x. There's our 4 times a number, right? And we're going to subtract 5. So there is 5 less than 4 times the number. And we're going to equal 32. Now we can solve this. We can add 5 to both sides, right? And we get 4, x There's a 0 here, so I'm not going to put 8. 32 plus 5 is 37. So I've got 4x equals 37. And now I've got 4x equals 37. I want to divide each side by 4. And that's going to give me x equal 37 fourths. And I can call up my handy dandy calculator. And if I want a decimal number, I can take 37 divided by 4. And I get 9.25. X equals 9.25. Now, reading through this problem, I get that these are accurate numbers and not necessarily measurements. I could be wrong, so we didn't go with significant figures. We just left it as is. A case could be made to round this if you wanted to. And so we've got 2 significant figures, so we might round that to 9.3. But I wasn't seeing it that way, so I left it at 9.25. All right, so that's going to wind us up for this first little section of word problems. Remember to go back and take a look at some of the things we said that we should probably do in working word problems. One of those is going to be to find whatever unknowns we have and then define it. So we found that, hey, number up here is unknown. We defined it as x. Picture the problem whenever you can. There's not a whole lot you could do with this one, but in most word problems they're to do with real life. And there'll be things like pouring concrete or the pitch of a roof or how much water is in a tank. And so we can actually draw out a picture. If you don't know the definition of the thing that the question is asking you, go look them up. Sometimes it won't matter. But you want to check and make sure that you know what you're actually doing. And then finally go back and recheck your answer and make sure it's correct. For instance, we haven't done that with this one yet. Let's see if it actually works. We have an equation 4x minus 5 equals 32, and we said that it was 9.25. So 9.25 times 4 equals 37. And our original equation was minus 5, so we'll subtract 5. And sure enough, we got 32. All right, so there are some steps to doing word problems. We will continue to work on these and look at different types of problems. But I think this is a good start. And I hope you have an awesome day. Thank you.